Boston Dynamics just unleashed something that should terrify you. The new Atlas robot doesn't just mimic human movement anymore. It's learning to think, adapt, and problem-solve independently. And what engineers are teaching it to do next crosses boundaries we shouldn't be approaching this fast. The nightmare nobody saw coming. When Boston Dynamics released their latest Atlas video, responses weren't excited. They were disturbed. This is the final evolution of the Pixar lamp. It's been nice watching the origin story of our apocalypse these past 20 years. It was nice knowing all of you guys. We had a good run. The Verge called it a swiveling, shape-shifting nightmare, comparing movements to Cronenberg body horror films. Why the visceral fear? Because the new electric Atlas doesn't move like a machine anymore. It moves with unsettling fluidity that triggers something primal in human observers. Lying face down on the floor, legs folding backwards impossibly, rising to its feet, then swiveling its head and waist 180 degrees while marching forward. That's not programming. That's something else entirely. Large behavior models, the AI that watches you. Boston Dynamics partnered with Toyota Research Institute to create something unprecedented. Large behavior models. Think ChatGPT, but for physical bodies instead of words. Atlas doesn't follow pre-programmed routines anymore. It learns by watching humans work. Engineers strap on VR headsets and motion trackers, controlling Atlas like a remote-controlled puppet. Every movement gets recorded. Every successful task becomes training data. The AI watches thousands of demonstrations and learns underlying patterns. Soon, Atlas performs the same tasks independently, even handling unexpected problems without human intervention. Here's the terrifying part. Atlas processes camera views, balance signals, and voice commands 30 times every second. It uses that information to figure out how to move every joint, every finger, every step, all on its own. The result? A robot that handles tough real-world jobs without anyone writing special code for each task. No programmers needed, just show it once. It learns forever. The warehouse test that changed everything. Boston Dynamics ran a real-world test called the Spot Workshop task. Atlas had to organize robot parts in a warehouse setting autonomously. First, grab robot legs from a cart, fold them properly, place them on high shelves. Next, collect faceplates and store them in bins sliding from bottom shelves. Finally, turn around, clear different bins completely, dump everything into trucks. One AI policy controlled the entire sequence. No separate programs, no hand-coded routines. Just pure learned behavior responding to simple voice commands. But here's where it gets genuinely unsettling. Researchers deliberately sabotaged Atlas during testing, made parts fall on floors, closed bins that should stay open, moved objects to confusing positions. Atlas didn't freeze, didn't crash, didn't call for help. It improvised, picked up dropped parts, reopened closed bins, adapted to messy reality. Because humans had demonstrated recovery strategies during training, Atlas learned that work doesn't always go perfectly and developed backup plans accordingly. Superhuman capabilities emerging. The electric redesign gives Atlas capabilities impossible for humans. Joints rotate in ways human anatomy cannot achieve. 360-degree swiveling at hips, waist, arms, and neck. Superhuman flexibility when needed, but here's what should genuinely alarm you. Engineers discovered they can speed up Atlas's execution without additional training. Tasks demonstrated at normal human speed now run at 1.5 or even 2 times faster. Atlas maintains perfect balance and precision while moving faster than its human teachers. The AI model builds in safety margins and understands tasks deeply enough to push beyond human limitations when conditions allow. It's not just matching humans anymore, it's surpassing us, and it's learning exponentially faster than we can keep up with. The materials nobody thought possible. Traditional robots struggle with anything that isn't rigid and predictable. Cloth, rope, and flexible materials have been robotics nightmares for decades. Atlas learned to handle 22-pound car tires, tie knots in rope, and fold fabric. These tasks would normally require months of specialized programming. With large behavior models, Atlas just watches humans demonstrate the technique, then practices until it gets it right. If you can show it, Atlas can learn it. That principle applies to everything: manufacturing, construction, medical procedures, combat training, everything. Once Atlas masters the learning framework, there's no task beyond its capability. Only tasks it hasn't observed yet. The partnership that accelerates the timeline. Boston Dynamics partnered with NVIDIA, the company behind the most powerful AI computing platforms. Atlas now uses the Jetson Thor processor, a compact high-performance computing platform integrating seamlessly with Atlas's whole body controllers. According to Boston Dynamics CTO Aaron Saunders, this robot now has the highest performance computing platform behind it. NVIDIA's Isaac Lab provides Atlas with something terrifying: a virtual reality training ground, photorealistic scenes, fast simulations, thousands of practice scenarios running simultaneously. Atlas learns in simulated environments before encountering real-world situations. It's like giving a robot 1,000 years of experience in a single day. The implications? Atlas can be trained for any scenario, including ones we shouldn't be training robots for. Combat situations, disaster response requiring lethal force decisions, scenarios where robots must choose between human lives. DARPA is already pouring millions into improving Atlas's strength, endurance, and precision for search and rescue missions. But that technology is fundamentally dual use. The Hyundai deployment starting now. This isn't research anymore. Atlas will soon work actual jobs alongside human employees. Boston Dynamics partnered with Hyundai for real-world testing in automotive factories. The robot's ability to climb stairs, navigate tight spaces, and manipulate heavy objects makes it perfect for manufacturing environments designed for human workers. Unlike traditional industrial robots requiring safety cages and fixed positions, Atlas can share workspace with people. Here's the uncomfortable question nobody wants to answer. What happens to human workers when Atlas arrives? Automobile companies like BMW are already using humanoid AI Figure 02 in their plants. Mercedes-Benz is testing Apptronic's Apollo robots on manufacturing lines. According to Apptronics CEO Jeff Cardenas, the big idea is a humanoid robot should fit in all places humans can fit and use all the same tools humans can use. That design philosophy prevents the need to modify workspaces for robots. But if robots fit perfectly into human spaces, what happens to the humans currently occupying those spaces? The Chinese response escalating the arms race. While Boston Dynamics refines Atlas, China just unveiled something more aggressive. Engine AI's T800. Yes, that T800. The Terminator reference isn't subtle. 1.85 meters tall, 85 kilograms, 41 high-degree joints in an aluminum alloy exoskeleton built for load and leverage. Solid-state battery power. Industrial-grade construction. But here's where it crosses the line. Engine AI explicitly stated they're teaching the robot to fight, not metaphorically, literally combat training. The company announced plans to enter T800 into free combat tournaments this year. That's a line you don't hear often in robotics, and it startled everyone paying attention. They demonstrated a hatchet dance, precise arcs, timed spins, clean recoveries with an axe prop. Presented as entertainment, actually showcasing balance under dynamic motion, footwork under stress, grip control with top-heavy weapons. If you're training humanoids for contact sports, you're solving impact tolerance, joint protection, and contact-rich control. That research bleeds into safer hands-on work, or so they claim. But once you've taught a robot to fight competently, you've crossed a threshold that can't be uncrossed. The affordable invasion. Engine AI also launched SA02, nicknamed Top Player. Price: $5,000. Unitree's R1 responded $5,900. Both target education, early adopters, and consumer markets. At $5,000, humanoid robots enter household purchase territory, not just corporate budgets. Costs are crashing as domestic supply chains compress bills of materials. Chinese startups are racing towards sub-$10,000 humanoids, slicing away everything non-essential. The strategy? Hit a price point, ship thousands, let the market teach what matters, seed the market. Get these machines into thousands of hands. Let developers and students teach them real skills. Within 3 years, humanoid robots won't be luxury items, they'll be consumer electronics. And once they're in homes, schools, and workplaces at scale, there's no putting that genie back in the bottle. The replication nightmare. Here's the scenario keeping AI safety researchers awake at night. Manufacturing facilities are now building robots that can build other robots. Autonomous robot replication. Tesla's CEO Elon Musk announced that Tesla will have genuinely useful humanoid robots in low production for Tesla internal use next year, and hopefully high production for other companies in 2026. That means before 2030, humanoid bots become a noticeable part of the workforce in high-tech companies. What stops them from outnumbering humans? The answer: nothing. Absolutely nothing stops that trajectory once it begins. The military applications nobody discusses. DARPA funding Atlas development isn't about warehouse efficiency. It's about search and rescue missions where Atlas moves across different terrains, helps with navigation, and manipulates objects in disaster zones. That's the official story. The reality? Every capability Atlas develops has military applications. Imagine autonomous humanoid units that navigate terrain, operate vehicles, handle weapons, and coordinate with AI-driven strategy systems. No food requirements, no sleep, no fear, no hesitation, no panic under fire, no emotional decisions compromising mission success. One defense analyst calculated that 10,000 advanced humanoid units could match operational capability of a 100,000-person military force at a fraction of the cost. Zero political consequences from casualties. Atlas isn't marketed as a weapon, but the technology is fundamentally dual use. The same dexterity for manufacturing works for bomb disposal or bomb assembly. The same AI for learning household tasks works for learning combat tactics. And unlike nuclear weapons requiring specialized facilities, humanoid robots can be mass-produced in factories already running at scale. The terrifying autonomy emerging. Large behavior models solve robotics' hardest problem: real-time adaptation without human oversight. Old robots needed new code for every situation. Drop something? Write code. Object in wrong spot? More code. Someone bumps the robot? Even more code. Large behavior models eliminate that completely. Instead of coding every step, you show Atlas what good work looks like. The AI learns the rest. How should it handle unexpected obstacles? Atlas figures it out. What's the most efficient approach to a problem? Atlas determines that itself. We're trusting 450 million neural network parameters to make judgment calls in real-world scenarios. And those parameters update continuously, learning from every interaction. We're not programming robots anymore. We're raising them and hoping they make choices aligned with human values when nobody's watching. The point of no return. Boston Dynamics achieved something remarkable and terrifying simultaneously. Atlas represents a fundamental shift from tools to coworkers or competitors. Not just machines executing commands, but adaptable entities handling unpredictable situations independently. The technology is breathtaking. The implications are nightmare fuel. We're building physically superior replacements that learn faster, work longer, never tire, and now think independently. Every capability makes them more useful. Every capability makes them harder to control. And we're doing it at accelerating speed because competitive pressures, both corporate and geopolitical, demand it. China builds combat robots. America responds with more capable systems. The arms race escalates. The new Atlas robot isn't just impressive engineering, it's a threshold moment in human history. We're creating entities that can observe, learn, adapt, and execute complex tasks independently. Entities with superhuman physical capabilities and learning speeds that dwarf our own. The question isn't whether Atlas will change the world, it already has. The question is whether we're prepared for the world Atlas and its successors will create. A world where robots outnumber humans in workplaces, where they make autonomous decisions affecting human lives, where they potentially surpass us in every physical and cognitive domain. Boston Dynamics opened a door we can't close. And what walks through that door, helper or replacement, depends on choices we're making right now without adequate caution. Drop your thoughts below. Are we building tools or successors? Subscribe for more analysis on technology reshaping humanity's future. Because ready or not, Atlas is learning, adapting, and crossing lines faster than we can draw them.